Hello everyone. So today we have a calculus problem trying to prove the limit of a function using epsilons and deltas, quote unquote. Limit as x approaches 2 of the function 5x minus 4 equals 6. So trying to prove this limit, and we arrive at this limit, the statement, really from intuition, or as I approach 2 for x, the statement 5x minus 4, it looks like it would approach 5 times 2 minus 4 equals 6. So what I'm trying to get at here is our intuition tells us what the limit should equal, and from here on out we're just trying to prove this. Now, when we say the limit as x approaches a of a function equals L, the statement right here, there's a definition, that's actually a definition, there's a definition to that. And the definition is as follows: given any epsilon greater than 0, there exists a delta greater than 0 such that an absolute value f of x minus L is less than epsilon whenever 0 is less than absolute value x minus a is less than delta. So yeah, a lot going on there. Epsilon is like a number that's given to you that tells you how close you want to get to the function. Okay, because if you're saying the limit exists, then I can basically get as close to the limit as I can, my function in itself. Well, that's what that epsilon is for. The delta here is the measure that you can go away from a on the x-axis that allows you to do that. And that's what that statement with 0 less than or equal to absolute value x minus a is less than delta tells you. Now I'm including 0 on the other side because you're technically not allowed to plug in a into your for your limit, right? And what all that means is going back to when you first looked at limits, when we said what does limit as x approaches a number, the word approach meant you can't actually consider the actual value of the function, you're just getting close to it. So that's why we put that right there, a 0. Okay, and a couple more things here I just want to give you as like more tips, like here in this problem, but more really in the future. This delta generally relies on epsilon and a, not on x. You'll see a lot of the time when you're doing a proof that you'll see people say, oh, delta equals epsilon over x plus 7, something along those lines. Not going to happen here, but as a reminder, delta is relying on epsilon, not x. Okay, and we'll get to more into that into another video, but just keep that in mind always. Also, that your delta is not unique. There are infinite answers that work. Once you find the delta, any delta that's smaller than the one that you found, that'll work as well. And the last thing here, where I have 0 less than or equal to x minus a, absolute value less than delta, implies absolute value f of x minus a less than epsilon. All I'm saying here is that that delta relies on epsilon, and that this statement makes this statement right here. Okay, so in reality, x minus a less than delta, that whole part is really what we want to work with here at the end, because that implies f of x minus a is less than epsilon. All right, so how do I actually proceed with these problems? In math, sometimes it's easier to reverse engineer something than go in the reverse process. So what we often do with these epsilon delta problems is we start with the part where you have f of x minus L is less than epsilon, or in our case, it was 5x minus 4 is my function, and 6 is what I'm claiming the limit is equal to. The L is less than epsilon. And what I'm going to do is as follows. I'm going to basically work with the inside that you see here in the absolute value, 5x minus 4 minus 6. And I'm going to use some algebra to simplify that a bit. So you get 5x minus 10 is less than epsilon, and I'll go why I'm doing this in a second. That's the first thing. The next thing I'm going to do is, notice how you can factor 5. So let's factor a 5 out. Now, let me do this now on the same line. I'm going to actually put the 5 outside the absolute value. We're allowed to do that. And sorry, that shouldn't have been 10. Oops. That should have been 2. So let me write the what I had there originally with the correction, excuse me. Factor the 5 out, you get quantity x minus 2. And as I just said, I can factor the 5 out of the absolute value. So you get 5 times absolute value of x minus 2 is less than epsilon whenever 0 is less than x minus 2 is delta. And here's what I'm trying to do, or see if you can see this. Notice how this statement is looking a lot like that. And with these linear epsilon delta proofs, that happens like a lot. And the last thing I'm going to do is I'm going to divide by 5. And the reason I'm doing this is because it's really hard for me to get an expression that looks like this from the given information by just looking at it. So I manipulated it to look like that, which I could do. And yeah, I arrived at this place where you have x minus 2, absolute value of x minus 2 is less than epsilon over 5. And yeah, I'm saying to myself, well, you know, if you look at these two statements, it looks like your delta would have to be epsilon over 5 for that to work out. Now, this is important. I'm saying this as an educated guess. I still need to prove the statement, okay? So all of this is like your kind of, sometimes people say it's your side work here, but we actually need to prove this. So for the proof, the way it works is actually pretty straightforward. You will pretty much follow all your steps backwards. And that's very common with these types of problems. And the way it works is we're going to start with the definition as such when it says given epsilon greater than 0. So you're always given this epsilon. And what I'm going to do is I'm going to let delta equal epsilon over 5. So now as I wrote in the definition that let delta greater than 0, well, I'm going to let the delta be equal to epsilon over 5. And what I'm going to do is this. This is the next step, which is kind of strange because I don't think we do this often in math. We're going to write the word consider. And I'm going to say, hey, let's consider this statement. I'm going to go and write the statement where you have 0 less than or equal to absolute value x minus 2 less than delta. But instead of delta, I'm going to replace the delta with what it's equal to. It's epsilon over 5. So, right, as I said earlier, in an epsilon delta proof, you can work technically, this is what you work with. This is what your whole proof is relying on. So we can work with this. And what we're going to do here is we're just going to build ourselves up back to f of x minus L is less than epsilon. How do I do that? I'm just going to kind of reverse my steps with my work earlier. I'm going to multiply both sides of the inequality by 5. And I really don't need the part where it's equal to 0 because I'm going with the f of x minus L less than epsilon part. That's where I'm trying to reach to. There's no greater than 0 there. Or 0 less than, excuse me. So the next thing is this. Again, I'm reverse engineering this. I'm going to distribute the 5 back inside. And 5 times epsilon over 5, that cancels epsilon. And then I'm going to rewrite 10 as minus 4 minus 6 is less than epsilon. So we have proved our limit here. So we said let delta equal epsilon over 5. Consider the statement. And all I did here was write statements that absolutely are true here. We're using properties about inequalities. So all of this is valid, okay? And all I was doing really was algebra, and it was the algebra that we were doing earlier. So really the soul of this is when you did your work over here, okay? But your actual proof goes back to what we wrote over here. All right, well, I appreciate your time. Thank you so much, and I hope this helps.